Welcome back. In our last video, we covered the absolute basics of object-oriented programming, also sometimes called OOP. This time around, we're going to increase our knowledge of object-oriented programming and delve into some more intense and fun examples. As a quick review, we can think of a class as a blueprint for an object. And when we use the word object, we're literally talking about an object in real life. That's what this paradigm was based off of. A class defines data and methods of modifying or using data for any object you can create. Now remember, when I say a method is just a function that is inside of a class. So after you've created the class, you can use that class to create an object and use that object in your application. So remember, class, blueprint, object is the thing built with the blueprint. If you watched the last video, you might remember that we created a person class, and we attached some attributes and some methods to that person class. This time around, we're going to flesh out that person class and make it a little more flexible while also learning some new and very important principles. As a reminder, if you haven't watched the previous video yet, please look at the description down below because you're going to be lost if you haven't. So as you know as a human, I know as a human, people aren't just a simple list of attributes. We can break down people into attributes. We can sort them by their age. We can sort them by their gender. We can sort them by their nationality, but that's not really what it means to be a person. Those are just attributes of a person. So this time around, what we're going to do, we're going to take that person class and we're going to flesh it out. We're going to make these people living, breathing entities that have a bit more use and function inside of our program. So what are some things you like to do as a person? I'll tell you one of the things I like to do most is read books, all different kinds of books. There's probably things you like to do: play basketball, jump on a trampoline, breathe, eat, sleep. These are all things that could be methods in the person class. So we're just going to take a look at one example for now of things that a person could do. And since this is my lesson, I'm going to use read a book. We're going to jump over to our code editor and we're going to see how we can integrate read a book functionality into this person class. So here we have the person class that we created in the last video. Now you're going to notice we have all of our same attributes here. So how do we define a method? And remember, method is just a word for a function inside of a class. Well, it's actually super easy. We're going to define a method the exact same way that we would in our normal code. We're just doing it inside of this class. We're going to make this method void because we don't need any data back. So we're going to say void read a book. We're going to put the parentheses there and we're going to make some curly braces. Now what should we have happen in the read a book method? Well, since we're trying to keep this simple and help you understand the principles, we're probably just going to focus on having some print statements now to print something to the terminal. So let's have it print out a message that says, how about this .name, which is going to print out the person's name, just read a book. IQ increased by 1 point. So whenever we execute this particular method, the IQ of the user will need to go up. So how are we going to achieve that? Really simple. If you remember last week, we can use this .IQ ++. Remember, ++ is just shorthand or syntactic sugar, as people in the computer science community like to call it. That is basically saying add 1. Now we have this method read a book that prints out a message and adds the IQ +1. So what are we going to do with this? Well, let's go to our list of people that we have here. You can see we have the same people that we listed out last week. We still have our for each statement here, which is going to list all the people. But down here, I've added a new line of code. So if you'll notice the comment, it says, let's use our new read a book method. Let's run it on people 0. Now, just in case you forgot, when you see people bracket number bracket, that basically is which index in that list you're trying to access. So when you put 0 in there, it's accessing the very first entry into that list. I know for humans, we usually start at 1, but when you're working with computers, 0 is generally the first entry. And then you'll notice we're using dot, which is how we call a method of an object, and then we're using our read a book method. That's all we have to do. Now let's go ahead and run our program and see what happens. You're going to notice we have our list of people printed out like normal, and then at the very bottom you can see a message that says, Jason just read a book. IQ increased by 1 point. There might be an issue with this application that you've noticed. When we're calling people 0, we really have no way to know who that's going to be unless we look at our code. For this application, since we only have 4 people, that's actually going to be pretty easy to do. But imagine if you had an application that was fetching hundreds, thousands, perhaps even millions of records from a database or remote API. So this is definitely a weakness in this program. So how can we fix that? Now the most obvious way you might be thinking is simply to add an if statement inside of our for each loop here to check for the person we want. So why don't we go ahead and say if person.name equals Jason, then we are going to run person.readabook. Let's comment out this call here, because we don't want Jason to read too many books or he might get too smart and realize he shouldn't be working on these videos anymore. Let's run our program. All right, so if you look at this output, you can see now up at the top it says Jason read a book, IQ increased by 1 point. This actually worked and it worked fine. I wouldn't say this is an elegant solution because then every time you want to make an update, you're gonna have to put if statements inside the for each loop. It's needlessly branching code and creating a slower application and more complexity for no reason. So as you might recall from previous videos, Dart has a slew of built-in functions when you're working with lists. And one of them is called indexWhere. We actually used this in a previous video. If we look at the code editor now, you're gonna see that we've modified our original statement to run the read a book function. So instead of people 0 read a book, which might be Jason or might be not, we've added some code. So this code uses that indexWhere function. So inside of those brackets, we're running people.indexWhere. And then for the argument, we have a comparison. We're taking the element and we're looking to see if the element name equals Jason. Remember, you have to use 2 equal signs here. So this should return us which number Jason is in the list, which will be the same as typing in people bracket 0 dot read a book or people brackets 1 read a book, whichever one corresponds to Jason. But this time, we don't have to know that number beforehand. So why don't we go ahead and see if this code works? Well, look, this works too. We're actually getting the exact same functionality. But I don't know about you, when I look at this particular piece of code, I think it's actually very hard to read. And then again, you're looking in here and we're having to hard code Jason, we're having to hard code comparisons. It's not very elegant. So how could we do this better? Dart actually has another function that we could use to do this, and it would be slightly more elegant. Instead of using if statements inside of the for each loop or having to figure out what the index is in order to run this function, we can use something built into Dart called singleWhere. Now, if you notice, we're running people object singleWhere method, and we're passing the same argument that we did in the other function, but this time we're checking for Jeffrey, and then we're running our read a book method chained onto that. This is more elegant, it's easier to read, and it lets us work with things that humans identify and understand better, which are names. Humans are good with numbers, but it's not very easy for us to remember large lists, whereas we can remember names with relative ease. So let's go ahead and run this code and see if it works. You can see that it properly found me without specifying that index number at all. Great, this is so much easier to do. We've got our singleWhere statement. I think this is a solution that we can live with. Now let's go ahead for a moment and try to break our code on purpose. We only have 4 people in this list. What happens if we input a name that is invalid? You can see for this name, we have put in Flambotanalaminio as the name. Now you know that's not on the list. I don't know that as the programmer because I'm probably getting data from some remote service or database. Let's go ahead and run this code and see what happens if we purposely put in faulty information. Oh, good Lord, this is quite the error. All right, so we've got an unhandled exception, which is another way of saying error, bad state, no element. So what this is saying is that there is no element found in this list where the element name equals Flabotanalaminio. One thing to notice, Flutter and Dart are relatively good at sending back usable and actionable error messages. So if you take a look here, you can actually see the line in our program where the error is occurring. So if we had a more complicated program, you'd want to look at this information and realize the error is in the file oop2-5.dart on line 34. Let's check up here and see if that corresponds. It does. So now that we know which line the error is on, we're going to go ahead and go back to VS Code or whatever IDE you're using to get some more information. So VS Code is great in that if we just mouse over singleWhere, we can find information about this function, or method as it would properly be called. So let's look at the documentation for the singleWhere statement. It returns the single element that satisfies test. It checks to see if the test element returns true. If one element satisfies test, that element is returned. So pay attention. This would actually not be a great use case for us if we had more than one Jeffrey, but for now we're not going to worry about that. If more than one matching element is found, it throws a state error. And if no element is found, it returns the result or the or else statement, which we're not going to worry about right now. Thankfully, Dart is equipped with something called the try-catch method, which is actually going to help us solve this problem with relative ease. So now we've jumped back to the code editor, and I'm going to show you how the try-catch block that I mentioned earlier works. As you may guess, you start it by typing the keyword try, you're going to put curly braces, and then down here you're going to put catch, and you're going to put inside this argument E. Now that E is basically the error message. So if you want to display or log that error message in some way, you can use that variable. Today we're not going to, but I did want you to know what it was for. So how does this work? Anything that's inside the try block, if it generates an error, it will execute this code down here. So you'll notice I cut and pasted our previous errorful code in here, and now I'm going to type a message that says, naughty programmer, this person is clearly not found. So what would happen is if this people.singleWhere throws an error, whatever kind of error it is, everything in the catch block is going to execute. Now right now we're just going to put a simple error message. Let's go ahead and see if this works. Well, okay, you can see that naughty programmer, this person is clearly not found, worked. I did make a typo in naughty, let me fix that. But otherwise you can see that the code worked. Now let's go ahead and put in a name that we know is valid. Like let's go ahead and put Jason once more. Let's run that code again. And you're going to notice that it did not return the error message. Instead it said Jason just read a book and gained 1 IQ point. The try-catch block is an amazing way to catch and respond to errors. Now, the one caveat and weakness to the try-catch block is it really only returns if you're using functions, methods, classes that return or throw errors. If somebody's code doesn't return errors in the way that Dart is expecting, the try-catch block will not be useful. But for most well-done code, including basically every package that is default in Flutter and Dart, it's going to catch those errors and help you solve these problems easily. So as you guys probably all know, people don't just read books. So let's go ahead and look at some pre-packaged functionality I've added to this class. I'm not going to make you watch me type these out. I wrote a method read romance novel, which minuses your IQ by 1. I'm using the this minus minus shorthand. And then it prints this name just read a romance novel and lost 1 IQ point. We have learned a code, learn from Jeffrey on YouTube. Now this one adds 5 to your IQ, which is about accurate. And it prints out a statement as well. We have a method called have a birthday, which increases your age by 1 and issues a happy birthday message. We have get nickname. This one's a little more exciting. If the name is not empty, it's going to write that you just got a new nickname and you're now known as whatever the nickname we entered is. Otherwise, we're going to throw our own error. Now, if you'll notice, when we're throwing this error, we're just using the generic error object. You can be much more specific, but for the sake of this demonstration, we wanted to keep things simple. We also added a method called move to a new country, which functions exactly the same way as get a new nickname. If the country is not empty, meaning someone put proper input, your nationality is changed to the new country. And then it's going to print a statement. If country is empty, it's going to throw an error. Now there's one last note I want to make about these methods, and there's a little bit of shorthand we haven't seen before. You're going to notice here we have this.iq plus equals 5. So you'll remember this IQ plus plus adds 1. This is just shorthand to add 5. So instead of saying this.iq equals this.iq plus 5, you can just write this.iq plus equals 5. Okay, so we're back in this application and we're kind of going to leave things as it is, but we're going to go ahead and experiment with the try-catch block because as you'll remember, we just made some methods that actually throw errors if there's a problem. So right here, I've gone ahead and I've created a try-catch block that checks to see if element.name equals Jason, have it read a book. And if it doesn't, it's going to print an error that says there was an error with this person. But because Jason has such a high IQ and loves reading, we're going to make him read books 3 times. You can see what I've done here is not the best programming practice, but I've copy and pasted the same code 3 times. Let's check and see if this code works. You can notice we still have our list of people, and then we have Jason just read a novel and gained an IQ point 3 times. Perfect, it looks like our code is working. Let's double check it by entering something random and see what happens. A can of Coke filled with mud. I'm fairly certain this is not a person on our list. Let's go ahead and try it out. Oh, there was an error with this person, but then the other 2 function properly. Great, so we can see that our error catching is working, we can see that our try-catch block is working, and that our read-a-book method is working. So our code is executing properly, but surely there's a better way we can write this instead of just using 3 try-catch blocks. You might remember from previous videos, when we want to reuse code, we've created a function. A method is just a function inside of a class. So let's go ahead and do that. Let's create a function called read-a-book so we can reuse some of our code at least. Void read-a-book, and then we're going to put our curly braces, and inside of the read-a-book function, we're going to put a try and then a catch block. Now, let's look at something. Since this function is not inside of the person class, we're actually going to have to pass this function as an argument a person. So let's just call it a person object named person. So I've already deleted the 3 try-catch blocks that we previously used. And now I'm going to go in here and I'm going to use this person object. So what do I want to do? Person.readabook. It's very simple. We only need that one line of code since we've already passed the person object in here. What should we have happen in case there's an error? I'm going to say print, this person was not found, or there was an error. Perhaps he got sucked into a black hole. Not a very useful error message, but it will serve our purpose for today. Now we're going to use our brand new read-a-book function. Now I do want to leave you a small note. You might say, Jeff, there's a method called read-a-book in the person class, and there's also a function called read-a-book in the main application. It's bad practice naming 2 functions the same thing, but I did want to give you another example of how scope works. These are able to coexist peacefully because they exist in different areas of the application. You wouldn't want to do this in normal circumstances, but it is good for illustrating our point. We've got our read-a-book function here. So now what we need to do is we need to call our people list. We're going to run singleWhere once more, and then we're going to say element.name equals Jason. But remember, we wanted Jason to read this book 3 times, so let's just go ahead and, again, not best practice, let's copy and paste this code 3 times and test the application once more. Well, it does work. This is a little cleaner and easier to read than the previous method, but I am so confident that we can do better than this. So what else could we do? We could create a for loop and set it to run 3 times. We could create a do while loop and set it to run 3 times. But guess what? Dart actually has built-in functionality that makes this crazy easy that I want to show you now. We can actually delete all this code. We can even delete this read-a-book function that we just created. We don't need it. It turns out the people who developed Dart built this functionality for us. It's great. So what we're going to do, we're going to go back to our main function. We're going to create a new try-catch block. We're going to call to our people list one more time. People.singleWhere. And this time, instead of element, we're going to call this person because this would make it easier to read and understand. And so much of code is just making sure the people that follow or your future self can understand what you're doing. We're going to use person in that argument and say person.name equals Jason. And we're going to run the method read-a-book on him. If this doesn't work, we're just going to print an error message that says, error, very useful error message. I want to make sure the try-catch block works before I move on. As you can see, Jason just read a novel and gained 1 IQ point. It worked properly. But if you'll remember, I told you there's an easier way to have Jason read 3 books. This is called method chaining. So if you do 2 periods here instead of 1 after your singleWhere clause, you can call read a book, and then you're going to do 2 periods. You can call read a book again, 2 periods, read a book again. Now let's test this application. Look, it works. Jason just read a novel and gained 1 IQ point 3 times. So notice how easy this was to read and execute and understand. I'm not saying there's not a place for using individual statements or using loops, but in our particular situation, this is a much easier way to do it. So now let's jump to our next file and have a little bit of fun. So you'll notice here, I still have the same try-catch block, but instead of Jason just reading a book, we're going to have Jason read a book, have a birthday, move to a new country, Brazil, get the nickname in Brazil of Pale Phantom, and then read 4 romance novels because he's so depressed at the way the Brazilian people are treating him. Let's see what happens. Can we really chain 9 entries here together? I don't know. I think it's going to work, but my computer might melt. Wow, this is crazy. Everything worked. Every single one of our methods ran without fail. It looks great. To recap what we've learned in this video, we have learned how to attach methods to our classes, which allow us to manipulate data and have objects do things or change. We've learned shorthand. We've learned the minus shorthand, and we've learned the plus equals shorthand for quickly and easily adding and subtracting numbers. We've learned how to use the try-catch block to execute a method or function and to respond to that function or method differently if there's an error or if there's not an error. And we've also learned how to throw our own error. And last but not least, we have learned the power of method chaining on an object. I hope you're really beginning to see the power of classes and objects. They aren't, though they can be, just simple lists of data. They're living, breathing things that can have an immense amount of attributes. They can have functions that allow them to do various things, some important, some small. And they're packaged together in a way that's just easy to understand. They make logical sense because we're taking real-world things, blueprints and objects, and we're assigning them to computer code. It's easy to understand what an object is compared to some other computer programming paradigms. When we come back, we're going to look at a new way to add more power and flexibility to the class object system that we've been learning. Stay tuned and we'll see you then.